This is topic 3, and under topic 3 we're going to discuss formulas. We're on page 7 of the manual, and we're going to give a definition of a formula, and we're going to discuss some applications with a rectangle, a triangle, complementary angles, supplementary angles, and vertical angles. So let's start with the definition. Definition of a formula is a relationship involving two or more variables. For example, you may be familiar with the formula distance equals rate times time. We might use the symbols here, D for distance, R for rate, T for time, and the equation is D equals R times T, which we usually write as RT, and there are three variables in this equation. So D, R, and T. You may also be familiar with a formula concerning interest. Simple interest paid. If we know the principal and the rate, and we know the time, then we can calculate the interest. So we abbreviate this as I for interest, P for principal, R for the rate, and T for the time. Then we have I equals PRT. We have four variables. So this gives us some examples of a formula, and let's just go over the term here, the definition of relationship involving two or more variables. So some applications of the formula can be applied in the case of a rectangle. So here we have a rectangle, 4 sides, and we're going to call L the length of the rectangle, and W is from here to here, it's the distance from here to here, is the width. So the perimeter is the distance all the way around, so we take twice the length, L is the length, plus twice the width gives us the perimeter, which is the distance all the way around, as if we were to walk it. So if this were 20 and this were 10, we'd walk 20, 10, 20, 10, we'd walk a total of 60. Now, another formula that we can get out of this is the area. And the area A equals the length times the width. So we have two formulas now and here which use variables. So the perimeter formula has three variables. P, this stands for L, the length, and W. The area formula has three variables, A, L, and W. So we can solve either of these formula if we have two of the three variables involved. For example, we can solve for P if we know the length and the width. So if I know L and I know W, I can calculate what P is. If we know P and L, then we can solve for W. So let's say we know what the perimeter is and we know what L is, then I could set it up so that I can solve for the other variable. So in general, to solve an equation, one must know the values of all the variables except for the one we wish to solve. So if we wish to solve for W here, let's say we want to solve this, we must know P and L. Okay. If an equation has four variables, one must know three of them to solve for the fourth. So So those are the basic rules regarding formulas and how we solve for them. So that's rectangular is one example of a formula. Another one that we can look at is the triangle. So here we have a three-sided figure where the lengths are A, B, and C. And then we have the height or the altitude drop down, forming a right angle right here. This little intersection here is called a right angle, so it's 90 degrees. And the perimeter is the sum of the three sides, so A plus B plus C. And the area of this triangle is given by multiplying the base here, which is B, the length of that, by the length of the height, H, and dividing by 2. Or we can write 1/2 of B times H. B is the base, and H is the height. So from the triangle, we can get out two simple formulas. In the case of the perimeter, there are 4 variables involved: P, A, B, C. If we know 3 out of the 4, we can calculate the 4th. For example, if we know A, B, and C, we can calculate the perimeter. If we know the perimeter and A and B, we can calculate for C. In the case of the area formula, there's only 3 variables involved: A, B, and H. In order to solve for any one of these, let's say we wanted to solve for H, we would have to know B and A. We're going to see how we can use this information when we do examples later on. Okay, so complementary angles. Here again, we have a 90-degree angle formed between this line and this line. Complementary angles are angles that sum to 90 degrees. So A plus B equals 90 degrees. So essentially there are 2 variables here. We know one of them, and we can calculate the other. So B is 90 minus A, or A is 90 minus B. For example, if I knew this was 50, this would have to be, B would have to be 90 minus 50, or 40. Sum of the 2 would have to equal 90. The only difference with supplementary angles as compared to complementary angles is that the sum of the angles must equal 180 degrees. And again, there are 2 variables here. If we know one, we automatically know the other. Let's say I knew this angle A was 60 degrees. B would have to be 180 minus 60, or 120 degrees. Once I know one, I automatically know the other. Vertically angles, we get vertical angles if 2 straight lines cross, then the opposite angles are equal. So here we have 2 lines that cross, and in this case, the angle A, right in here, equals the opposite angle, C, and the angle B, which is in here, right here, is equal to D. And we know that A plus B equals 180, so A plus, because it's a straight line, and A plus D equals 180. So if we make these 2 statements equivalent and cancel out the A, we get B equals D. So let's go over that. We've got A plus B equals 180. And then we have A plus D, which is a straight line. So since A is common to both of these, we can cancel it, and B equals D. So that's what we've attempted to do right here. So now let's look at some examples of the applications of formulas. And this is on page 8. We're now on page 8. And we're going to break these down. There's 3 individual problems. So example 1 here, example 2, example 3. And these are all examples on how we use formulas. So let's break them down and look at them individually. In example 1 here, on the application of formulas, we're told that P equals 100 and L equals 40. We're asked to find W in the formula. The perimeter is twice the length plus twice the width. Now, what we do is we're told P is 100, so we're going to substitute right here. P is 100. We're going to substitute for that right here. We know that L is W. L is 40, excuse me. So we substitute for the L right here. And here we have plus 2W because we're solving for W. That's our unknown. Note, in order to solve for W, we must know P and we must know L. And we're given that in the problem. This problem has 3 variables. We know 2 of them, so we can solve for the third. 2 times 40 gives me 80. And in this case, we will see if we bring the 80 to the left side, we get 20. Now, usually we reverse the procedure, bringing the variable to the left and the number to the right, but it really doesn't matter. What we're doing here is bringing the 80 to the left-hand side, subtracting it from 100, and we get 20. So now we have 2W, which is the same as writing 2W equals 20. We divide this side by 2, we get W. We divide this side by 2, and we get 10. So W equals 10 in this problem. Now, now going to look for H in the formula for the area of a triangle, which is half the base times the height. So here I'm going to go through this stepwise. We start with this formula, and we want to solve for H. We're given this formula. This is what we start with. We're given this formula, and we want to solve for H. The first thing is we multiply each side by 2 because we want to remove the denominator on the right. We want to remove this 2. So if I multiply this side by 2, the left and the right, I get rid of the denominator, the number 2 on the bottom. So I get 2A equals BH. Now I reverse the equation because I want to solve for H. H should be on the left. So all I've done is reverse this, put this here and that there. Now and say, well, they could both have minuses on them, but if they both have minuses on them, that's the same as plus. So if 2A equals BH, BH equals 2A. I can just reverse the whole equation. So now I have H on the left. Why do I have H on the left? Because I want to solve for H. Now I want to get H by itself. So that must mean that I have to divide this part by B, so the B's cancel. Here the B's cancel. I'm left with H. And since I divided this side by B right here, I have to divide this side by B. So I divide by b so that the h term is isolated, and I finally come up with h equals 2a plus b. These cancel here, and I get that answer. Now, here we have another example, which is not in the manual, but I just made it up here. R equals ST over VW, and we want to solve for the W. We want to solve for this term right here. R equals ST over VW. So the first thing we do is multiply both sides by VW. And the same way we remove the denominator in the last problem, we want to get rid of this VW on the denominator. So multiply the left by VW, multiply the right by the VW. So now remove the brackets and rearrange left to put unknown term first. So here's W, which is unknown on the left. This is identical to this. There's no difference. We remove the bracket. We just change the order. When we multiply three variables together, the order doesn't matter. So I'm putting the W first, and because that's what I want to solve for. So we've got WVR equals VW over ST, and I still have this VW here. So the VW here and the VW cancel. These cancel with the V, the W cancel with, and I'm left with ST. So WVR equals ST. Notice I have the variable that I'm looking for on the left. I don't want the V and the R. I'm going to divide by VR. The V's will cancel. The R's will cancel. And since I divided the left term by VR, I must divide the right term by VR. So the V's cancel, the R's cancel, I'm left with W, and here I have ST over VR as the answer. Now, example 3, we're supposed to find each of these angles here, and in this case, these angles are supplementary angles because they sum to 180. Why? This is a straight line right here. So the straight line consists of 180 degrees. So the sum of this angle and the sum of this angle must equal 180. So 2x minus 20 is this angle. This angle is 3x, and the sum must be 180. Now we remove the brackets, get 2x minus 20 plus 3x, and we transpose the minus 20 to the right side, add it to the 180, and we get 200. 2x plus the 3x gives us 5x, so 5x equals 200. Divide both sides by 5, and I get x equals 40. Now I go back up here, and I put the value of x equal to 40 into each of the angles. So 2x minus 20 is 2 times 40, which is 80, minus the 20 gives me 60. Now I take this one, 3x, substitute for the 40, because that's what I found x equal to, 3 times 40, and this equals 120 degrees. Notice that the 60 plus the 120 equal 180. So yes, by checking that, we have some indication that the problem was done correct. We will continue in the next section with page